In this video, we will be configuring static routes and default routes. Static routes will allow all of our routers to have full connectivity throughout our network. Default routes will allow our laptops and routers to be able to go outside of our network to the internet, represented here by one router and one server. Once static routes and default routes have been configured, the two laptops should be able to ping the server 8.8.8.8. So let's go ahead and turn on all of our ports and configure our IP addresses. We'll start with our ISP router and our server. Interface gig01, no shut. IP address 192.168.0.2. Router 1 will be 192.168.0.1. Also interface gig02, no shut, and IP address 8.1, since the server will be 8.8, using a /24. (8.8.8.8) for the server, /24 gateway, 8.1 for the ISP router. (0.2 was the ISP. 0.1 will be router 1. So the interface gig01. No shut should turn green. IP address 192.168.0.1/24. 0.0 go into router 2. No shut. IP address 192.168.1.1.0. Router 2 is using all of its gig ports, so we can configure T, interface gig00, no shut. If I press up, it goes like into the last command. If I press up again, I can easily interface gig01, no shut, gig02, no shut. Let's interface gig00 again. IP address 192.168.1.2. That is going to router 1. Interface gig02. That will be going to laptop 2. So IP address 10.1.10.1/24. Gig01 is going to router 3. IP address 192.168.2.1. Like so. Router 3 will need gig01 as well as gig02. Enable configure terminal. Sorry about that. Configure terminal. interface gig 01, no shut, IP address 192.168.2.2, 255.0, interface gig 02, no shut, IP address 10.1.20.1/24, and laptop 3 will be 10.1.20.2. The gateway of 10.1.20.1. Now that all of our routers and laptops have been configured with IP addresses, we will now place static routes on all of our routers, verifying connectivity from each router to each laptop, and then we will place in default routes and verify connectivity from our laptops to the internet, or here just the server. Okay, so router 1, IP route. Router 1 already has connectivity to the 192.168.0.0 network and the 192.168.1.0 network, but it doesn't have connectivity to 10.1.10.0, 192.168.2.0, or 10.1.20.0. So our first static route will be to 10.1.10.0, the subnet mask 255.255.255.0, and we will be using a next hop as a reference. So 192.168.1.2. Since in order to get to the 10.1.10.0 network, it must first go through router 2's gig 00 interface, which is 192.168.1.2. We also need an IP route to 192.168.2.0, and the next hop will stay the same, 1.2, and we also need a static route to the 10.1.20.0 network, 192.168.1.2. But before these routers and laptops can send this traffic back to router 1, we have to configure static routes on router 2 and router 3. So router 1 should be able to ping router 2 because it's directly connected, and it should now be able to ping laptop 2 since it has a static route to the 10.1.10 network, and laptop 2 already knows how to get to router 2 because of a direct connection, and router 2 already knows how to get to router 1 because of a direct connection. Router 1 will not be able to ping router 3 since router 3 does not know about the 192.168.1.0 network. Router 1 now knows about 192.168.2.0 and the 20.0, but router 3 does not know how to send that traffic back to router 1. So we'll move on to router 2. Router 2 needs a static route to the 10.1.20 network, and that's it. It doesn't need static routes to router 1 or to laptop 2 or to router 3. Those were all directly connected. Router 2 only needs one static route, so IP route 10.1.20.0. Next hop will be router 3, 192.168.2.2. router 2 should now be able to ping laptop 3, router 1, and laptop 2. Router 3 still does not have connection to router 1, nor does laptop 3 though. So now router 3 must be configured. IP route. Router 3 needs 2 static routes, one to the 10.1.10 network, since it does not know about laptop 2. So we'll use 10.1.10.0. .0. Next hop will be router 2, 192.168.2.1, and it also needs a static route to router 1, 192.168.1.0 network, 255.0. Next hop is still router 2. Now, router 3 knows how to reach router 1 and laptop 2. Router 2 knows how to reach laptop 3, as well as all of its direct connections. And router 1 knows how to reach router 3, laptop 3, and laptop 2. We will test ping all of our interconnections. However, we still do not have a full connection to the internet until we configure default routes on all of our routers. We'll also need a default route on the ISP to go back to our network, and that will only be for instructional purposes, since that is not how an ISP will actually configure their router. But just so that we have full connection from our network to our simulated internet, we'll use that default route on the ISP router as well. So let's go ahead and test how much we can ping. Right now, laptop 3. We'll test ping to laptop 2 and then to router 1. Ping 10.1.10.2. Might time out for the first ping, but should return replies. Alright, let's see where the error is. We'll have to look at our routing tables on router 2 and router 3. Show IP route. I should see 10.1.10.0 network via 192.168.2.1. Gig 01 is 192.168.2.1. Can router 3 ping laptop 2? 10.1.10.2. We have not set an IP address on laptop 2 yet, so there is no point trying to ping an IP address that does not exist. That's my fault. I forgot to configure the IP address on laptop 2, 10.1.10.2, 255.0, default gateway 10.1.10.1. I should have already configured Gig 02 on router 2, and yes. So now laptop 3 should be able to ping laptop 2 and we have replies. So we have configured our static routes correctly on router 2 and router 3. Now let's verify if laptop 3 can ping router 1, 192.168.1.1. It may time out for the first ping, but we have replies from router 1 to laptop 3. And let's just verify that laptop 2 can ping router 1 as well. .1.1, we have replies. We have full connectivity on our internal network. None of these devices will be able to ping the server yet until we configure a default route on router 1, router 2, and router 3. We will start by our ISP router first. IP route. A default route uses 0.0.0 with a 0.0.0 subnet mask. That is saying a static route to any network with any subnet mask, and the next hop of 192.168.0.1. I believe this is 192.168.0.2. 0.1 will be router 1. So this is saying send any traffic to any network to router 1. Again, that was just for instructional purposes. That is not how an ISP router would actually configure its connectivity. Let's use default routes on our 3 internal routers. For router 1, IP route 0.0.0.0. Next hop would be 192.168.0.2, the ISP router. If I show IP route, we will see now that we have gateway of last resort is 192.168.0.2 to network 0000. We also have a static route with a star to the 000 network via 192.168.0.2. Star means that this is the candidate default route. This is saying that router 1 can forward traffic aimed to any network to the 192.168.0.2. So if router 1 receives a packet that is aimed to a network that is not within its own routing table, it will send it to the ISP router and let the ISP router send that packet to that unknown network. Router 2 will still need a default route in its routing table, otherwise router 2 will drop all of laptop 2's packets that are going to the server. IP route. Next hop 192.168.1.1. Gateway of last resort is 192.168.1.1 to network 0.0.0.0. Lastly, router 3 locate a default route. Next hop 192.168.2.1. So now our three routers have default routes configured so that laptop 2 and laptop 3 should be able to ping the server, which is 8.8.8.8. So we will test our default route by going to laptop 2's command prompt and ping 8.8.8.8. And we have replies. Router 2 and router 1 had to resolve this request, so it timed out the first 2 times, but now laptop 2 can ping 8.8.8.8 without a problem. And let's just verify that laptop 3 can also ping 8.8.8.8, and it gets replies. So there you go. That is how you configure static routes and default routes so that your network can have full connectivity.